Student brand, this is your Shiva sir. Today topic is electricity. Electricity. So electricity in in the previous live class, I explained about the previous live class. I explained electricity until electricity explained. So related to that, so we discussed few points. So electricity. Now we are going to discuss few more points related to electricity. So we'll work out on it. Okay. Electricity. Come on, everyone, join to the live class. So we'll discuss electricity. In this electricity topic, so we are going to discuss about in this live class, we are going to discuss about difference between resistance and resistivity. Difference between resistance and resistivity. So hi everyone, welcome to the class. So in this class we are going to discuss about resistance and resistivity. So what is resistance? Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Okay. Resistance is the phenomena of opposing electric current. SI unit of resistance is ohm. 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 So welcome to the class. Very important concept we are going to discuss. Welcome everybody. Warm welcome to the class. Come on, join to the class. Yes, so now we are going to discuss about difference between resistance and resistivity. So now we are going to discuss about resistance and resistivity. What is resistance? Resistance is nothing but, yes, very good. So those who want to learn, those who want to prepare, so you can join to the class. So now I'm going to the electricity topic in that resistance and resistivity. So now I will explain about resistance and resistivity. Come on. Welcome to the class. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistance is ohm. Come on. So we are taking the formula. So hi. Anirudh Singh, hi, and Tim Cham, hi, yes, Hamal, so yes, Amula. Okay, so very good. You can learn physics. So here I am taking the first point. Very. Now I am going to discuss about very important topic, very essential topic, very crucial topic. Come on, everybody, be ready for the class. Come on, very important class, important chapter, important question. Very important. Come on, join to the class. Come on, join to the class, everybody. So resistance R equal to rho into L by A. Resistivity rho equal to RA by L. RA by L. That is the first point. Coming to the second point. SI unit of resistance is ohm. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. This is second point. Coming to the third point, symbol. This is the symbol SI unit of. So SI unit of resistance. So ohm meter. So this is also symbol. I am considering the fourth one. Resistance depends on. Resistance depends on resistance resistance depends on temperature, length and area. So resistance depends on temperature, distance depends on length and area. Resistance depends on length and area. Resistance depends on length and area. Resistance depends on length and area. So resistivity does not depend on, does not depend on length and area. So it is also called physical dimensions. So resistance does not depend on. So fifth one, it depends on temperature. So depends on temperature. Resistivity also depends on temperature. Resistivity also depends on temperature. Resistivity also depends on temperature. Resistivity depends on temperature. Resistivity depends on temperature. Resistance also depends on temperature. Now you are considering, here you can see. So sixth one, depends on material. So very important. So 3 marks question will come for exam. Very important. CBSE grade 10 physics. CBSE grade 10. grade 10 physics. Even state ICSE. So CBSE grade 10 physics, very important chapter. Resistance, 3 marks question. Definitely I am saying this question will come for 3 marks in the board exam. Very important question, very essential question. So very motive question. So this question, so many times they asked this question in the exam. So make sure that you are learning very. Come on. Say like this, not like this way. Very important. Very important. Come on, so do like once. So you can see here, resistance, SI unit of resistance. What is the resistance? Resistance is nothing but, resistance is the phenomena of opposing the electric current. Resistance is nothing but phenomena of opposing the electric current. So resistance is nothing but phenomena of opposing the electric current. So electric current. Okay. So here I am considering like this. So resistance is nothing but phenomena of opposing the electric current, and so SI unit of resistance is ohm. Symbol of ohm is this one. So resistance depends on length and area. Resistance depends on temperature. Resistance depends on material of the conductor. Coming to the resistivity, very important. As I said many times, this question will come for exam. Very important. So related to resistivity definition. So resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. So we can also write resistivity in this format. So rho equal to R by L into A. Rho equal to R by L into A. Very, very important. I am saying this question is very, very important. This question is very, very important. Make sure that you are learning this point. Make sure that you are learning this point. Very, 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 very important. So resistivity is equal to resistance of the conductor per unit length and unit cross section area. Resistivity is equal to, by seeing the formula we can get to know, by seeing the formula we can get to know, by seeing the formula we can get to know resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. This is about resistivity. This is about resistivity. Come on. So here you can see resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. Here SI unit of resistivity is ohm meter. They will ask for exam. They will ask in the exam for 2 marks question. This is very, very important. Very, 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 very important. SI unit derivation, especially derivation they will ask. Especially derivation they will ask. Especially derivation they will ask. They will ask for 2 marks. They will ask for 2 marks. They will ask for 2 marks. So SI unit of resistivity is ohm meter. So symbol is this one. Symbol is this one. Resistivity does not depend on length and area. 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 Resistivity depends on temperature. Resistivity depends on material. Resistivity depends on temperature. Resistivity depends on material of the conductor. Material of the conductor. Material of the conductor. Material of the conductor. So here you can see. So resistance and resistivity, very, very, very important question. Either state CBSE or we can go for ICSE. Any board. So this question is very important. Sure short question, damn sure question, expected question in the public exam. You can check once in midterm, unit test, slip test. So annual exam, midterms. So you can go for a pre-finals, any exam. This is a question, important question for any exam. I am telling, this is very, very, very important. Make sure that you are learning this question. I am Siva sir. This is my channel, Student Zibran. In our unit test, slip test, annual exam, any of the exam, if you get this question, you can come and say thank you. Click our like button. Now you click our like button. Definitely remaining students, they will come and join and involve and learn the physics. Come on. Okay, so next. This is about resistance and resistivity. Resistance and resistivity. Very, 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 very important. Once again, come on. So come on, very, very important. Very, 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 very important. Okay, so make sure that you are learning this question. Come on, next question. Next question is resistors are in series combination. Resistors are connected in series combination. If you want to take a screenshot, if you want to note down, so I'm giving time, you can make a note of it, or you can scan it, you can take like a screenshot. Okay, very, very, very important. Very, very important. Make sure that you are practicing this one. Next one, we are going to the next question. Resistors are connected in series combination. Resistors are connected in series combination. Now we are going to the resistors are connected in series combination. So how can we identify resistors are connected in series combination and resistors are connected in parallel combination? How can we identify? How to do the problem? I am there. Always I am there. Here Siva sir is there. No fear. Here Siva sir is there. No fear. Don't worry about it. So we will solve any question. We will solve. Try to do it. Now I am going to the next one. Resistors are connected in series combination. Resistors are connected. Resistors are connected in. Resistors are connected in series combination. Series combination. Resistors are connected in series combination. So I am taking one resistor, another resistor, one more resistor. Like this, three resistors I connected. How I am connecting three resistors? Hi, Ayush and Rick Best Cook. Ayush, what is your question, Ayush? Can you tell me? So I am here. No fear. Shiva sir is here. No fear. So can learn physics. Right, come on. Tell me. What is your question? So R1 I am taking, R2 I am considering, R3 I am considering. So in the path, in this path, if the entire path, if the current is same, if the current is same, then that path, then that connection is called series combination. Here you can observe, I am taking the battery here, positive terminal, negative terminal, positive terminal, negative terminal, current is flowing like this, current is flowing like this, positive terminal, negative terminal, positive terminal, negative terminal, current is flowing, current is flowing. What is series and parallel? So series and parallel is nothing but, so the way resistors are connected normally in your house, 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 how the bulbs are connected, in your house, how the bulbs are connected. So in factory, in factory and function hall also, how the bulbs, how the bulbs are connected, how the electrical appliances are connected, how the electrical appliances connected. So based on that one, series and parallel, series and parallel. So how the bulbs, how the electrical appliances connected to the circuit, electrical appliances connected to the circuit depends on it. So we are discussing series or parallel, in our household, in our homes, we are connecting electrical appliances in the format of parallel combination. In our household, we are connecting electrical appliance in the format of parallel combination. Why you are connecting parallel combination? One, we can off the fan, we can on the switch, we can on the TV, we can off the fan. So like that, so different appliances we can on it separate, different timings, and different potential difference is required for different appliances. Different potential required, difference potential difference is required for different appliances. That is the reason, according to the connection, so these appliances are connected, so that is the reason we are dividing into series or parallel combination. Series combination in our function, so you can see in our function, if one bulb is mixed in a row, if one bulb is broken, if one bulb is not working, that entire row it won't work, in our household, especially in our homes, we are using parallel combination. Sir, what is parallel combination? Parallel combination is nothing but, I am explaining. So one by one I will explain. We will do the problems, how to get and how to derive the resistors are connected in series combination, resistors are connected in parallel combination. Everything we will discuss. Come to the point. Here I am considering R1, R2, R3, R1, R2, R3. Across R1 we are connecting voltmeter V1. Across R2 we are connecting voltmeter V2. Across R2 V2. Across R3 we are connecting voltmeter V3. So here positive terminal, negative terminal, positive terminal, negative terminal, positive terminal, negative terminal, positive terminal and negative terminal. Here I am taking the battery, current is passing from positive terminal to negative terminal. Here I am considering different resistance R1, R2, R3, R1, R2, R3, R1, R2, R3, R1, R2, R3. So potential difference, voltmeter is connected across R1 V1, across R2 V2, across R3 V3, right? Yes or no? From Ohm's law. from Ohm's law V equal to IR. From Ohm's law V equal to IR. So entire the path, current is same or not? Entire the path, current is same or not? Entire the path, current is same or not? Yes. Entire the path, current is same. Entire the path, current is same. That's why we are taking IS. Current in series combination, IS equal to I1 equal to I2 equal to I3 equal to I. So whatever the current is flowing from the battery, so that current will go through R1, R2, R3, R1, R2, R3. So very important MCQ. For MCQ, I'm telling very important point. Come on, so remember this point. Very important. What is that point? Concentrate here. So IS equal to I1 equal to I2 equal to I3 equal to I. Whatever the current is flowing from the battery, so the same current will flow through the entire circuit. The same current will flow through the entire circuit. That's why IS equal to I1 equal to I2 equal to I. So right, I hope it is very clear. So now we are going to the next one. So from Ohm's law, V equal to IR. From Ohm's law V equal to IR we consider. So from Ohm's law V equal to IR. From Ohm's law V equal to IR. V equal to IR. Come on. Very important concept we are discussing. Very important concept. So we know here resistance R1, R2, R3 are three different resistors across R1. Across R1 V1, across R2 V2, across R3 V3. So everybody hi, those are coming to the class, everybody hi. So come to the class, join to the class. So if you like this content, do like, share and subscribe to Student in the Brand. So click on like button, remaining students also they will come to the class. Here we are saying Vs equal to V1 plus V2 plus V3. So why you are taking Vs? What is the reason I am taking? What is the reason? I am telling one thing. What is the reason I am taking Vs? The reason behind this is the potential from the battery. So that is equal to whatever the potential is created. Okay, is there from the hi. So everybody hi. So and Parvaj hi and Sunhab hi, Nisar and everybody hi. So come to the point. So the potential difference across the battery here, that is equal to V1 plus V2 plus V3. So the potential whatever it is here from the battery, whatever from the battery, how much your potential is coming, the same potential is equal to V1 plus V2 plus V3. V1 plus V2 plus V3. Potential. Vs equal to V1 plus V2 plus V3. Come on. So now I am considering here. Rs equal to from here Vs equal to IRS. I is constant. That's why I am taking IS. So now we are taking IRS equal to IR1 plus IR2 plus IR3. So once again, IRS equal to IR1. IRS equal to IR1 plus IR2 plus IR3. So here, sorry for the inconvenience. Here you are saying, so I we can take common, I is common. I am taking common, IRS equal to, I you are taking common R1 plus R2 plus R3. Come on, I get cancelled. RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. This is the answer. You in series combination, you should understand one thing. In series combination, you should understand one thing. Add all the resistance. That's enough. That is the answer. You must add all the resistance. In series combination, you'll get the answer. This is Siva sir. This is a student the brand. So in series combination, you must add all the resistance. resistance, then you'll get the answer. So come on, here you can go to the next one. So Rs equal to R1 plus R2 plus R3 here. And one more point, very important point, very important point. Rs equal to Nr, Rs equal to Nr. So Rs equal to R1 plus R2 plus R3, R1 equal to Rs equal to very important. Here I am telling very important 3 points I am telling. Everybody listen. Come on. Very important. I am saying this is Siva sir. This is my student the branch channel. So this point is, so if the current, so in the series combination, Is equal to I1 equal to I2 equal to I3 equal to I. So by seeing this one, we can understand one thing. That is, in series combination, current is same. Current is same. So if you are taking resistance Rs equal to R1 plus R2 plus R3, we have to add all the resistance. All the resistances. R1 plus R2 plus R3. If n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. So that is very important. Make sure that you are learning this point. Very important. Highly important. You have to compulsory learn this question. Resistors are connected in series combination. So R1, R2, R3. So current is same in entire series combination. This point will come for 1 mark. Very important. This question will come for 1 mark. Very important. This question will come for 1 mark. The entire derivation they will give for 3 marks. Once again. Shakshay Kumar, hi. Okay, so once very important. So this one is very important. This is very important. If n number of resistors are connected in series combination, Rs equal to Nr. So Rs equal to R1 plus R2 plus R3. Rs equal to R1 plus R2 plus R3. Very important. I am saying, sir, please repeat the last topic. So last topic is about difference between resistance and resistivity. So I will explain. Already I said that is very important. Highly most important. Resistance is the phenomenon of opposing the electric current. Resistance depends on length, area. SI unit of resistance is ohm. Resistance depends on temperature. Resistance depends on material of the conductor. Resistivity. Coming to resistivity is nothing but resistance of the conductor per unit length and unit cross sectional area. Resistivity does not depend on length and area. SI unit of resistivity is ohm meter. Very important. I am saying my name is Siva sir. My channel name is Student the Brand. So SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Fix in your mind. Yes, ohm meter. Very important. And one more thing. Resistivity depends on temperature. Resistivity depends on material of the conductor. So 3 marks question. Each and every point is a diamond. Each and every point will give 1 mark. And the formula formula related to formula they will give for 3 marks. 3 marks question will come from that formula. Or resistance depends on temperature. So here how it will be, I will tell one thing. So yes, extraordinary question he asked, so I will tell. So what is your name? Showing for that. So I hope this is resistors are connected in series combination completed. Resistance connected in series combination completed. Very important. Very important. He asked one question that I'm explaining. That also very important. Very important. Very important. Very important. Normally I am taking the conductor. So I hope your name. What is your name? Shaunak. So Shaunak, we can see, just observe here. Here electrons are moving inside of the conductor. Charges are moving inside of the conductor. Yes or no? Charges are moving inside of the conductor. So there is a drift speed. There is a drift speed or not? There is a drift speed or not? Yes or no? There is a drift speed. Yes or no? There is a drift speed. Yes or no? Yes. So drift speed is nothing but when the electrons are moving, charges are moving inside of the conductor. So this electron will hit the another electron. This electron will hit the another electron. This electron. So this electron it is moving 2 meter per second. Suppose 3 meter per second. Suppose so 4 meter per second. Suppose 5 meter per second. Suppose 6 meter per second. Suppose 8 meter per second. Suppose if average speed of an electron is taken as drift speed, average speed of an electron is taken as drift speed, because when it is hit, so if the electron will hit the next one, so this speed will decreases, this speed will increases. So sometimes this electron will hit the lattice core of the conductor, so this electron speed also decreases. So by overall you are considering that is a drift speed. That is a drift speed. Now when you hit the conductor, so listen carefully, very important concept. You ask this question. So why don't see normally, so if all the students are moving in a row, so running race is there. In a running race, why everyone are not reaching to the goal? Why they have different speeds? Can you answer the question? Because everyone are moving in the same path. One they have more speed, one they have less speed. That's enough. It depends on their path and colliding each other. So it depends. So that's why they have different speed, right? So direction also we are taking particular direction. So here we are not moving in a particular direction. Sometimes overall entire current is moving in a particular direction. Current Current is a scalar quantity. So it is not following vector law of addition, right? So vector laws. That is the reason current is a scalar quantity. Why? Because electrons are moving in different directions with so hitting the lattice core with a different speed. That's why it is moving with a different speed. So overall they are moving in the same direction. That's why drift velocity also they are considering. And one more thing. So I am telling. So he asked one question. When temperature increases, the collision between the electrons will be more. Then what happens? The movement, more collisions will take place. So it won't go forward. It won't go forward direction. So the number of collision will take place. So there itself, then so because of temperature, resistance increases. So collision will increases. So that heat we are using in heating effect of electric current. That heat we are using as a heating effect of electric current, like iron box, electrical heater, room heaters, and electrical cookers, like this. Those heat. What after, if you increase that time of bombardment, time of collision, then heat will be produced. That is the reason you can observe the electrical heater coils will be in the form of round shape, because to increase the time of collision, increase the time of collision. That is the reason the coils. So the conductors are in the form of coils. So when it is moving in a circular manner, so more collision will take place, more heat will be produced. That heat will be utilized for room heaters, electrical oven, electrical cooker, and room heaters, like so many. So number of applications you can take. I hope, Saunik, your doubt is clear. That is the reason if temperature increases, resistance will resistance will increases. Thank you so much. If you like this content, if you like this class, click on like button, click on like button. This is Shiva sir. My channel name is Student the Brand. So if you like the content, if you like the explanation, please do like. And if you like this channel, please do like, share and subscribe to Student the Brand. You will get content with proper explanation. So this is Shiva sir. This is Shiva sir. My channel name is Student the Brand. Okay, so it depends. So it depends on one semiconductors, it will be depends. Okay, so sometimes the temperature increases, so resistance decreases. So depends on the property of the metal, right? Okay, so come to the point. Next one, we are going to the next one. Next one we are going to the next one. Next one we are going to the next one. Next one now. What we are doing? Resistors are connected in parallel combination. 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 Very important in the previous board exam. Parallel combination in the previous board exam, related to this, related to household connection, related based on this one, they asked one question. Based on this one, they asked one question. So very important. Wonder of knowledge. Hi. So hi everyone, welcome to the class. So this is Shiva sir. So my channel name is Student the Brand. So I'm teaching physics. So come to the class. We'll go to the resistors are connected in parallel combination. So I am taking three resistors. 1, 2 and 3. So here all the starting points, if you connect at one point, all ending points if you connect another point, all starting points at one point, all ending points to the another point. Those you are connecting and connect to the battery, connect to the battery switch. So now you are considering, current is passing. This is R1, R2 and R3. So current is passing from positive terminal to negative terminal. That is the reason we are called it is as a conventional current. So Hindi thoda आता, please excuse me. I will learn in future. Definitely I will teach. Someone said, yes, Asher, the current flowing through why should be series or parallel. So we are taking, now we are considering. So here I am taking voltmeter I'm considering. According to the junction, it depends on. Okay, so positive terminal, negative terminal, current is passing like this. Okay, so parallel combination only. If the current is dividing, definitely it is a parallel combination. I1, I2 and I3. So in this and bridge also, junction is the current is dividing. So parallel combination. If the current is dividing, voltage same. Very important. Voltage is same. Yes, very nice. Voltage is same. Why voltage is same? So in parallel combination, you can see, you can explain. I will explain because we are working on this chapter. So if you are deviating from the chapter, so I will explain. Okay, so one by one I will explain. So first let me complete this one. Here you are considering R1, R2, R3, I1, I2, I3. Current is dividing in the parallel combination. I1, I2, I3, R1, R2, R3. So here from the battery current I is going. Here from the battery current I is flowing across R1, I1, across R2, I2, across R3, I3. So the potential difference is same across the three resistors. Because of dress code, because of my teaching aid, so it's happening like that. So whatever the situation, we have to do our work. So I1, I2, I3, I1, I2, I3, I1, I2, I3, R through R1, R2, R3, through R1, R2, R3. I am saying current is dividing in parallel combination. Current is dividing in parallel combination. Current is dividing. So I current is moving, passing, flowing, going from the battery. So through the resistors R1, R2, R3. So I1, I2, I3. Here you have to understand one thing. Potential difference is same from Ohm's law. From Ohm's law, V equal to IR, I equal to V by R. Potential difference is same. That is the reason I am taking IP equal to V by RP. So we can take effective resistance, equivalent resistance. So we can take effective resistance, equivalent resistance, total resistance, anything we can take, anything we can take. The words are different, but final concept is same. Final concept is same. Now you are considering P equal to V by RP. Now you are taking, so the current coming from, the current flowing from the battery, so that is in parallel combination equal to I1 plus I2 plus I3. Very, 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 very important. So here we have to go with the background music. Very, very important, I am saying. So very, 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 very important this question. So keep in this mind. IP equal to I1 plus I2 plus I3. IP equal to I1 plus I2 plus I3. Very, very important for MCQ. Thank you. So here I am telling. Yes, of course. Voltage is comma, I is inversely proportional. Yes, related that also questions will come. We will do while doing problems. I'll explain. Yes, so when potential difference is constant, I is directly proportional to I inversely proportional. So see, we don't know how much current is flowing here, how much current is flowing. So that is the reason I'm taking normally IP equal to I1 plus I2 plus I3. So IRP equal to, sorry, now you are considering VRP, right? I is same, right? So V by RP equal to V by R1 plus V by R2 plus V by R3. So now we can take V common. Now we can take V common. We can take V common. So 1 by RP equal to V common 1 by R1 plus 1 by R2 plus 1 by R3. So we will get cancel. So 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. Very, 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 very important. So 1 by RP equal to 1 by R1 plus 1 by R2. 1 by R2, 1 by R2. Come on, 1 by R3. Very, 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 very important. This concept I am saying myself, I am Shiva sir. This is my channel, Student D Brand. This question is very important. 1 mark question. 1 mark question. 1 mark question also will come. 1 mark question. 1 mark question in the board exam. I am saying very, 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 very important. Practice this concept, right? So very important. I am saying here this 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So current, this question I am telling, this question will come for 1 mark. This question will come for 1 mark. The entire explanation will come for 3 marks. And this one, Ohm's law, will come for 1 mark. 1 mark. If n number of resistors are connected. So I'm telling one more point. I'm telling one more point. I'm telling one more point. One more point. One more point. I'm telling one more point. So one more point. One more point I'm telling here. Very, very important. Very important point. So that is very, very important point is that one. So I'm telling here. So you can see here. If n number of resistors are connected in parallel combination, 1 by Rp equal to n by R. So Rp equal to R by N, RP equal to R by N. Very, very important. So make sure that you are practicing this one. Make sure that you are practicing this one. So Vimal, hi. So make sure that you are practicing this one. I am saying myself, I am Siva sir. This question is very important. Thank you, thank you. I KS Gaming something. So can I know your name? And Yashesh, hi. Can I know? Thank you. Thank you so much. Kushal Singh. Very good. Thank you for coming and joining and involving class and enjoying class. So I'm in ninth. Very good. Excellent. So welcome to the class. Everybody welcome to the class. So learning physics is very important. That is only one thing we need. So okay. Oh, thank you. Thank you so much, everybody. Thank you so much. Okay, so come to the point, come to the point, come to the point, come to the point. One more I am telling, one more I am considering here. If n number of resistors are connected, that is, I am next topic is each and every word is a diamond. Each and every word is a diamond. Each and every word is a diamond. That is sure. I am telling next one, next line. Next question is each and every line, each and every statement is like a marvelous, mind blowing, amazing, marvelous, mind blowing, amazing, amazing. Amazing question. So again I'm telling. So next line I am telling heating effect of electric current. Heating effect of electric current. I am telling myself. I am Siva sir. This is the student in the brand. Next topic. Keep in mind. Note down. Underline each and every point. Each and every point. Very, very, very important. Come on. Ready? Are you ready? Are you ready? 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 Yes, H equal to I square RT. There is nothing but heating effect of electric current. But I am saying each and every line heating effect of electric current. You are saying. Now I am taking potential difference equal to each and every line is a diamond. I said each and every line is a diamond. I said yes or no. I said each and every line is a diamond. Each and every line is a diamond. Is it a diamond or not? You check and let me know. If it is not a diamond, you say this is Siva sir. My channel name is Student the Brand. If it is not a diamond, each and every line, each and every point is a diamond. I am saying how it is diamond. You see here. So I am taking V equal to W by Q. V equal to W by Q. Heating effect of electric current. Heating heating effect of heating effect of electric current. Heating effect of electric current. Heating effect of electric current. Okay, so V equal to W by Q. W equal to V into Q. W equal to V into Q. So P equal to rate of doing work. P equal to rate of doing work. So W equal to VQ by T. W equal to VQ by T. W equal to VQ by T. So now V into Q by T, V into Q by T, P equal to V into I, P equal to VI, P equal to VI. So what of the energy is given to the conductor with a certain time equal to P into T, equal to P into T. We know P equal to VI. What of the energy is given to the conductor that will become in the form of heat. So V into I into T. We know V equal to IR. Yes or no? V equal to IR. V equal to IR. V equal to IR. Very, very, very important. H equal to I into R into I into T. H equal to I square RT. H equal to I square RT. This is also known as Joule's law of heating. This is also known as Joule's law of heating. This is also known as Joule's law of heating. Each and every line is a diamond or not? Each and every line, diamond or not? Let me know. Tell me, diamond or not? Diamond. I'm saying each and every line is a diamond. Each and every line is a important point. Each and every line is important point. Okay, so power equal to electrical power. Electrical power is rate of doing work. Rate of work done. Rate of doing work, rate of doing work. So here I am considering potential difference here from this V equal to W by Q. From this relation comes from, this relation comes from, this relation comes from, this relation comes from. Okay, so here I am considering V equal to W by Q. Potential difference W equal to VQ. So P equal to rate of electrical work. So here P equal to V, whatever the energy. So how much power to the conductor, how much you will give, how much time will give to the conductor, sometime only. That is nothing but whatever the energy is given, energy equal to power into time. With a certain time only will power. Okay, so the work will be done. The work will be done. Then only we can able to say. That's why E equal to P into T. So H equal to, anyway from B we can take, so from here you can consider, so P equal to VI, P equal to VI, so in the place of P we are substituting VI into T, so in the place of H equal to, so here V formula, what is the V formula, what is the V formula, V formula, P formula, I formula, yes or no? So very important here. Here you can see I equal to Q by T, 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 the rate of flow of charge, rate of flow of charge, rate of flow of charge is called current, rate of flow of charge is called, so gamer trade, so high, rate of flow of charge is called what? Current. Rate of flow of charge is called current. Rate of flow of charge is called current. Electrical power is nothing but rate of doing work. Electrical power is nothing but rate of doing work. V equal to IR. Ohm's law equal to V equal to IR at constant temperature. The potential difference across the metallic conductor is directly proportional to current flowing through it at constant temperature. At constant temperature, the potential difference across the metallic conductor. So that entire energy consumed, okay, consumed in the form of, so entirely energy consumed and it will be wasted. So the source of energy continuously gets dissipated entirely in the form of heat. Entirely in the form of heat. Whatever the electricity energy is, so that will be, okay, so dissipated, converted, the total energy will be converted in the form of heat. You can decide whatever the energy is released. Ohm's law is nothing but already explained, right? Ohm's law, there is nothing but at a constant temperature. Part I am explaining now, you can listen. At a constant temperature, 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 the potential difference across a metallic conductor is directly proportional to current flowing through it. The potential difference across a metallic conductor, across a given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. V equal to IR. Is it clear? If you like this video, please do like, share and subscribe to Student the Brand. So if you like, so you can subscribe. Again, you will be having live class. So now 6 p.m. we'll be having, and 9 p.m. also will be having live class. Come and join to the live class. We can check it one. So this is Siva sir. So from Student the Brand, now we are going to the next one. So applications of heating effect of electric current. So I'll tell the definition. So explain. Okay, so this topic is completely different. There are T types: paramagnetic, ferromagnetic, diamagnetic. So depends on the magnetic nature. Depends on the magnetic nature. The substance are decided. The substance are divided. Okay, so that is completely different. So I will explain. I will explain once magnetic effects of electric current comes. Sir, he is teaching 10th class current electricity. Yes, this is a CBSE Grade-10 physics. Electric current, CBSE Grade-10 physics. Electric current, CBSE Grade-10. So, current electricity, CBSE Grade-10 physics. This is Siva sir. So, you are listening CBSE Grade-10 physics. So, come on next to the topic, heating effect of electric current, heating effect of electric current, heating effect of electric current, heating effect of electric current. Salute. Okay, so come to the point. Next one, we are going to the next one. Applications of heating effect of electric current. Applications of heating effect of electric current. Applications of heating effect of electric current. What are the applications of heating effect of electric current? Electrical iron, electrical cooker, electrical oven, room heaters. All these examples for heating effect of electric current. If the heat is produced when the current is passing, if the heat is produced from the conductor, if you are utilizing that heat, if you are utilizing the so whatever the energy is consumed, that will be converted in the form of heat. Okay, so heat will be released, energy will be consumed. Okay, so that will be converted in the form of heat. So that heat if you utilize, that is nothing but heating effect of electric current. By sending the current through the conductor, that will convert in the form of heat. That heat if you utilize, that is known as heating effect of electric current. That is known as heating effect of electric current. So if you know any examples, you can type other than electrical oven, electrical cooker, iron box, room heater. So like so many are there related to heating effect of electric current. If you like this content, so you can do like, share and subscribe to Student the Brand. So this is your Siva sir from Student the Brand. And so if you like this, hey, hi. So Daniel, hi. So if you like this content, if you like this channel, so you can subscribe the channel. You'll get live class. So 6 p.m. will be having, 9 p.m. you'll be having. Okay, so we are doing problems. Now we are going to do problems. Till now I explained the concept. So once again I will recall all the topics. Just listen. Electric current. Come on, electric current. The rate of flow of charge. Now I will explain. About So now I will explain about recall the topic. I'll recall the entire topic. So once again, listen carefully. So I equal to Q by T. Very, very important. I equal to Q by T. Rate of flow of charge. One more question will come. Rate of flow of charge. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. Very, very important. One more question. One more question. Current is nothing but I equal to Q by T. Rate of flow of charge. The flow of charge through unit cross section area per second is called electric current. Rate of the flow of charge through unit cross section area per second, that is called electric current. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So this is about electric current. Quantization of charge plus or minus Ne on one electron 1.6 into 10 power minus 19 coulomb. Very, 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 very important. And in 1 coulomb 6.25 into 10 power 18 electrons. Very, 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 very important. Very, very important. Very, very important. Very, 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 very important. Come on, keep in mind this point. One electron, how much charge is present? 1.6 into 10 power minus 19. In 1 coulomb, how many electrons present? 6.25 into 10 power 18 electrons. So 6.2 plus means here positive charge, proton. There are two types of charges are there, right? Positive charge, negative charge. Positive charge represent proton, negative charge represent electron. Positive charge represent proton, negative charge represent electron. That's why we are taking plus or minus Ne. So plus or minus Ne. So very, very important. Make sure that so again you can join. We'll do problems. So 6 p.m. again 6 p.m. you can join. 6 p.m. class you can join. That time we are doing problems, electricity problems. There we will discuss more points. Come on. Next we are going to the quantization of charge, electric current. Next method we can go for electrical appliance. I am taking the cell cell, battery, 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 battery. Positive cell, negative cell, 1, 2. So this is cell, battery. Come on, battery. Third one, open switch. This is open switch. Next one, closed switch. Open switch and closed switch. Fifth one is resistor. Resistor. Sixth one is rheostat. Rheostat symbol, either this one or like this also we can take rheostat. Next one, ammeter, voltmeter. Next one, wire joining, wire crossing, bulb. So these are the electrical appliances. So the electrical appliance. Next one, next one we are going to the potential difference, potential difference, potential difference. Work done to bring unit positive charge. So I'm taking the conductor. So point A, point B, 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 point A, point B. So I'm taking work. We are doing some work to bring unit positive charge from one point to another point within the conductor. That is nothing but. So we are doing some work to bring unit positive charge from one point to another point within the conductor is called potential difference. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So SI unit of potential difference is volt, SI unit of work is joule, SI unit of charge is coulomb. 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 coulomb of charge. 1 coulomb of charge moving. 1 joule of work is done. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Coming to the electrical potential. Electrical potential. Electrical potential. Electrical potential. Electrical potential is nothing but we are doing some work to bring. So this is the required field. So this is the infinity. So infinity. So this is the infinity. We are doing some work. We are doing some work. We are doing some work. So infinity, positive charge, required field. So we are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field. That is called electrical potential. Electrical potential. Next one. So we are going to the next topic, resistance and resistance. So resistance is nothing but the phenomena of opposing the electric current. Resistance is nothing but phenomena of opposing the electric current. So SI unit of resistance is ohm. So SI unit of resistance ohm. Resistance depends on length. Resistance depends on area, and it is also depends on temperature and material of the conductor. Resistivity depends on yeah. So recalling, right? After recalling, I will take break. Thank you. So resistivity depends on so temperature and material of the conductor. So it does not depend on length and area. So next one we are going to the resistivity is SI unit of resistivity is ohm meter. So next one we are going to the resistance and resistivity completed. Resistors are connected in series combination. Rs equal to R1 plus R2 plus R3. So their potential difference is different. Current is same in series combination. Potential difference S equal to V1 plus V2 plus V3. From that Rs equal to R1 plus R2 plus R3. So parallel combination, potential difference is same, current is different. Ip equal to I1 plus I2 plus I3. V by Rp equal to V by R1 plus V by R2 plus V by R3. V we get cancelled. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is about parallel combination. Heating effect of electric current is very, very important. Already I said each and every word is a diamond. Each and everybody, every sentence, every line is a diamond. So make sure that you are learning that point. So next one, application of heating effect of electric current. Electrical cooker, electrical oven, so room heaters, so like that. Okay, like this, so many applications we can take. And the next one we are going to the next point is commercial unit of energy is kilowatt hour. Commercial unit of energy is kilowatt hour. Related to this one, they will ask. It's okay. You are a diamond, sir. Okay, thank you. Can't able to bear the sentences, words. Okay, come to the point. Next one. So commercial unit of energy is kilowatt hour. 1 kilowatt hour equal to 3.6 into 10 power 6 joule. So 6 joule, that is about commercial unit of energy. So and here we can go for one more point. Short circuit and overloading. Short circuit is nothing but the direct contact of live and neutral wire takes place. Then heavy amount of current will be taken from the. Very good. Someone said all for you. Yes, thank you. Correct. 1 kilowatt hour equal to 3.6 into 10 power 6 joule. And short circuit direct contact of live and neutral wire takes place. Then we can say short circuit. Overloading, heavy high voltage appliances on at a time. High voltage appliances on at a time, then heavy amount of current will be drawn from the main. Then so short circuit will happen. Yes, fuse is a safety device. So safety device, so it will be used in the circuit. When a heavy amount of current goes in the circuit, it melt and break the circuit. And also it protect the appliance. And also we are using safety. One more safety applications are earthing. So fuse and earthing. So a extra amount of current will be there in the circuit that will send to the ground. So these are the points. So I hope maximum points we discussed. Still few more points are there. Oh, thank you so much. But actually, थोड़ा थोड़ा हिंदी आता, थोड़ा हिंदी आता, थोड़ा not बड़ा नहीं आता, थोड़ा हिंदी आता. So समझ आता. Okay, fine. I will try to learn Hindi. I'll try to definitely learn Hindi and I'll teach. So definitely I will work out on it. Okay. So in future you will see my Aramya. Yeah, I remember. So in one of the classes you joined and okay, done. So we'll so again I will join at 6 o'clock. 6 o'clock you can join. Today 6 p.m. and 9 p.m. both the classes will be there. We'll do problems. 6 p.m. problems, 9 p.m. also problems. You can join at 6 p.m. Okay, sir. Then carry on with the. Thank you so much. But as of now, please adjust. So next, definitely within. No, not within. So very soon I will learn and definitely I will teach. Okay. Yeah, sir, can you explain heating effect of electric current? Just now I only completed. Janatana Kamiya. Okay, so definitely I will explain. So 6 o'clock you can join to the class. Again 6 p.m. I will take class. That time I will explain about. So again the points, if you have any doubts related to electricity, I will explain. So thank you so much for joining and attending. If you like this video, please do like, share and subscribe to Student in the Brand. And if you like this channel, you can spread a word to your friends and ask them to your friends to join to the class. So thank you so much. Signing off.